All right, today's lesson is about exploring solids. So first thing you got to know is what's a solid? Does anybody know that? Basically, I'll just dumb it down. It's basically a 3D shape. Another word we call it is a polyhedron. Now this is more specific. It's more of a geometry term. Poly means many sides, so many-sided shape would be a good definition. And the key thing about a polyhedron, it has no curves. No curves. All right, after that we have faces, edges, and vertices. These three kind of go together. If you have a shape that looks like this, and it's kind of an ugly cube, but we can talk about its faces, vertices, and edges. So a face would be like this shape right here. This shape on the front would be one face. Here's another face and another, and then it has even more that you can't see right now. So the faces are the flat shapes, and those shapes are typically like triangles, squares, and so forth. Edges are the next important vocab word. An edge is a line segment. So there's one edge. Here's another edge, another edge. So we have a lot of edges on this shape. So an edge is just a line segment. What an edge does is that it connects two vertices. So if you look down here, here is one vertex, and here is another vertex. And really a basic term for a vertex is just a corner. So how many corners does it have? So there's a bunch of them on this shape, and you can see that I'm making dots on the vertices. And once again, an edge connects two vertices. After that, we have a few other terms. We have the word base. Now base, please make this note out to the side. The base is not always on the bottom. The base is not always on the bottom. That's the critical thing you must get in your head. A lot of people just think base is on the bottom, always, always, no matter how it's laying. But if I have this shape, does anybody know the name of that one? This is a type of prism. It's actually called a triangular prism. The neat thing is it is named by its base. So what shape is the base? It's a triangle. However, is the triangle on the bottom? No. In this case, it's a rectangle on the bottom. It's not a rectangular prism, though. It's named by its base. So the key thing I want you to write about a base, the bases are always the two parallel and congruent faces. Oops. They're parallel and congruent. So if you look on either end of this shape, we have a triangle and another triangle. These triangles are parallel and congruent. That's why it's called a triangular prism. So bases are a really important topic when we're talking about prisms. Next thing we got to talk about is a regular polyhedron. Does anybody remember what the word regular means? Okay. It means that the shapes are all the same size. So all shapes and really that's the word faces, all the faces are the same size. They're all the same shape and size. So does anybody know an example of a regular polyhedron? There's one we talk about all the time. A 3D shape, so not just a square. Yeah. So a cube is that one we've talked about so many times. So a cube has a bunch of regular squares on it. And when a shape has a bunch of regular shapes on it, it usually has a special name. Cube is one of those examples. Another one is a triangular pyramid with all equilateral triangles. All right, up next we have a few other terms. We have platonic solids and cross-section. Anybody get the definition for platonic solids? 5 regular polyhedrons. So we're not going to talk about this too much, but can anybody give me an example of a platonic solid? Okay, regular tetrahedron. What else? Cube. Yeah, so I'm not going to make you memorize these, so don't worry about these. But some of these shapes have special names. The key one you better be able to recognize is a cube. That tetrahedron is what I mentioned earlier as that triangular pyramid. The next thing is a cross-section. So, for example, if you have a shape that looks like this, does anybody know what that's called? You might want to sketch it. This is one you have to be able to identify. This is called a rectangular. Second word, anybody got a guess? Prism, good. This is a rectangular prism. So if I say I want to see a cross-section, whenever I take this piece of paper and I slice it, so what would that look like? If you took this and sliced it, well, you'd take a view of what this area actually looks like. And when you kind of zoom out, it would look like this. What shape is that? Parallelogram. Yeah, that would be a good answer. That would be a good answer. Depending how this is actually sliced, it could be a rectangle, depending on the perspective and how it was sliced. So that's an example of a cross-section. You could also do that with a sphere. If you take a sphere and you slice it, most likely you're going to be left with a circle, or maybe even an ellipse if you're slicing it really funny. Right. So here's some examples of some basic solids that you have to be able to identify. And the key thing that I mentioned earlier is that some of these are polyhedrons and some of these are not. These over here are not polyhedra. Why? They have curves. These all have curves. These over here are regular polyhedra, or just normal polyhedra, and they have no curves. Basically, it's saying you better be able to identify these shapes. If you see this shape, you should be able to say the word sphere. If you see this, you should be able to say prism, and even more specifically, it's what type of prism? Triangular prism. This one, I don't like the word just pyramid, because we name pyramids by their bases. If I did this on this triangle, what kind of pyramid is it? What's the name of its base? Square. So it would be a square pyramid if I did that. I could also come out and do this. Now what's the name of its base? That would be a rectangular pyramid. So we always put two words when we're naming pyramids and prisms. So let's go down and look at example 1, see if we can answer these questions. It says, tell whether the solid is a polyhedron. So this is a yes or no answer. So for this first question, it's all going to be yes or no. So let's go through and do that first. Is it a polyhedra? So A, is it a polyhedra? Yes or no? Yes. Is B a polyhedra? Yes. Is C a polyhedra? No, and why? Because that curves. Because of those curves. Next thing, if it is a polyhedra, name it, find the number of faces, vertices, and edges. What? Does anybody know the name of this shape? I'd take triangular pyramid. I like that. So this one right here is a triangular pyramid. Does anybody know the name of B? So I heard octagon. Octagon means 8. Oh, it says 6. 6 is hex. So this is a, watch this, hexagonal prism. So even if you take this shape and turn it on its side, it would be sitting on a rectangle, but it's still called a hexagonal prism. And the last one we don't worry about because it's not a polyhedra. But we got to say one other thing. Faces, vertices, and edges. So we don't write the words. We say F, V, and E. So counting the faces, vertices, and edges. In my opinion, vertices are the easiest. Counting the corners. So let's do vertices first. 1, 2, 3, 4 vertices. I think edges are the next easiest. Edges. That's the segments, the line segments. So we can draw on these and it makes it easy when we're counting. 1, 2, 3, 4, 5, 6 edges. Now the most challenging. Counting faces is hard for some people because it involves a little bit of perspective. If you're looking at this shape, how many faces are there? 4. Oh, that's good. Okay. So I like the faces and edges because you can actually draw as you're counting. But faces, you can't really draw on them because perspective is involved. But there's actually 3 around this top area and then 1 on the bottom. So 3 and 1 makes 4 faces. Part B, let's go through that one as well. We need our faces, our vertices, and our edges. Once again, I think vertices is the easiest because you can put a dot on each vertex. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 vertices. Edges I also like because you can draw as you're counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 edges. And I think on this one, the faces are not that hard to count. Yeah, there are 8. So how can you count that? Well, there are 6 around the sides, plus a top and a bottom. So that's 8 faces. Good job. All right, here's a little trick that can help you figure out if you're counting correctly. So this little formula is called Eulers Theorem. It says F plus V equals E plus 2. So this is something that we can check. That means we can use numbers from a shape and plug them in. Does anybody remember the numbers? Let's see, I'll steal them. 4, 4, and 6. So 4, 4, and 6. So F, V, and E from part A. Let's plug them in and see if it works. F is 4. V is 4. Equals E, which is 6, plus 2. What's 4 plus 4? And then 6 plus 2? Does it work? That means we counted correctly. So why is this formula important? Because some shapes are harder to count on. And it's easy to make a mistake. But if you plug into this formula, it's like your checking mechanism. Another example is over here. They plug in their numbers and they show that it works. 12 plus 2 is 14. 6 plus 8 is 14. So when 14 equals 14, that means you counted correctly. This one is a little bit harder because there are a lot more faces, vertices, and edges. I'm going to give you a second to see if you can count how many faces, vertices, and edges are on this problem. All right, so when I'm counting, I'm going to do vertices first. 1, 2, 3, 4, 5, 7, and there's one in the back, 12. 12 vertices. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I think I got 18. Did you all get that? Yeah. All right, and now I'm going to erase these so I can count the faces. There's one in the front, 2, 3, 4, 5, 6, 7, 8. Did y'all get 8? All right, now we can plug it into our formula. F plus V equals V plus 2. So 8 plus the vertices of 12 equals edges plus 2. 18 plus 2 is 20, and 8 plus 12 is 20. Checks out. We counted correctly. All right, now we have an example dealing with those cross sections. That means you have a 3D shape and then you slice it with a piece of paper. So describe a shape formed by the intersection of the plane and solid. So these pictures are much better. They show the slice in much more detail than my little drawing did earlier. So we have to describe what shape is this one right here on A. It's a circle. From this perspective, it kind of looks like an ellipse, but it's actually a circle. I think this one on part B is pretty easy too. What shape is that? Pentagon. And then this last one, that's a rectangle. Some people like these. They think it's easy. Try these checkpoints and see how you do. All right, here we go. On 1, 2, 3, it says, is it a polyhedron? If it is, count the number of faces, vertices, and sides, and name it. So, is number 1 a polyhedron, yes or no? Yes. Number 2, no. Why? Because it has curves. Number 3, yes or no? Yes. All right, so what is the name of this shape? Pentagonal prism, good. And what's the name of number 3? Rectangular prism, because the base is a rectangle. Sorry, what did I say? Definitely a pyramid. How do you know it's a pyramid? A lot of people will put prism here. Because these sides, which are not the bases, are all triangles, and they go up to a common point. A prism will never do that. It will never have a bunch of triangles going up to a common point for prisms. That only occurs on pyramids. So now we just need our faces, vertices, and edges on these two shapes. So how many faces do we have here? 7. So there's your odd answer. So sometimes we do have some odd numbers. Vertices, how many? 10. And edges? 15. Good. Down here on our pyramid, how many faces? Good. 5. Vertices? 5 as well. And edges? 8. Nicely done. Now it's giving us some numbers down here, and it wants us to use Eulers' formula to figure out is it a possible polyhedron. So there's 34 vertices, 50 edges, and 16 faces. So that's where we use that formula. F plus V equals E plus 2. So faces are 16, and there are 34 vertices, and there are 50 edges. So 50 plus 2 is really simple, 52. Does this add up to 52? Oh, what is it? 50, duh. Yeah. So is this true? No. So they cannot form a polyhedron because they don't work in Euler's formula. Good job. One more remaining, and it's talking about some cross sections. So remember, cross sections are always going to be 2D shapes. You're never going to give 3D names for cross sections. So what's the cross section here? It's going to be a rectangle. This one's going to be a pentagon. And what's that last one? Triangle. Good job.